Good afternoon, children. This is Hanuman sir here. In the previous classes, we have learnt about rational numbers, right? So, the numbers which can be expressed in the form of p by q, where q is not equals to 0 for all pq belongs to integers, then they are called rational numbers. The word rational means ratio, so the q means quotient, right? So rational numbers can be converted into a decimal either by the long division method or by an equivalent rational number with the denominator as a 10 and then expressing the equivalent rational numbers as a decimals. So, and also we are discussing about terminating decimal expansion. So terminating decimal expansion is usually defined as a decimal number that contains a finite number of digits after the decimal point, right? And also we are discussing about non-terminating decimal expansion, right? Yes, a decimal expansion, a decimal is said to be a non-terminating repeating decimal. A decimal is said to be a non-terminating and repeating decimal if the divisor never gets completed and either a digit or a group of digits repeats itself again and again. Yes, so every rational number can be expressed either as a terminating decimal expansion or as a non-terminating repeating decimal. Yes, okay. So in this class I am going to take you on the same topic. So come to the sum. Yes, write three numbers. Write three numbers. Right? Three numbers. Right? Three numbers whose decimal expansion. Whose decimal expansion. Whose decimal expansion are non-terminating and non-recurring. Non-terminating and non-recurring form. Yes, so we need to write three numbers whose decimal expansions are non-terminating and non-recurring. So a decimal is said to be a non-terminating repeating decimal if the division never gets completed and either a digit or a group of digits repeats itself again and again. So that is non-terminating decimal expansion. And recurring after the decimal point, if we get a same number repeatedly, then it is recurring. Non-terminating means it won't be repeats again and again, right? So for example I am going to write, see, first one example, the first three numbers, the three numbers whose decimal expansions are non-terminating and non-recurring terms are, see, suppose I am going to take 0.10, 100, 100, 1 2 3 4 0, etc. If I take, this is 50, 5 00, 5 000, 5 1 2 3 4 zeros, etc. If I take, this is 90, 900, 9 000, yes, etc. If I take, this is, see, suppose what, 01, 001, 001, etc. If I take, this is 110, 1100, 11 000, etc. All these examples are non-terminating and non-recurring form, right? So non-terminating, a decimal expansion is said to be a non-terminating and repeating and also non-repeating decimal expansion if the division never gets completed and either a digit or a group of digits repeats itself again and again. So it is clearly seen that decimal numbers which do not terminate and have no repeating parts are called irrational numbers, right? So the decimals which do not terminate and have no repeating parts are called irrational numbers, right? So the opposite to rational numbers. So irrational numbers which cannot be written in the form of p by q, where q is not equals to 0 for all pq belongs to integers, right? Yes. So the another definition of an irrational number is the decimal expansion of an irrational number is non-terminating and non-recurring. Moreover, a number whose decimal expansion is non-terminating and non-recurring so is called irrational. So it is irrational, right? Okay. We'll okay. Then come to the second one. So that is find an irrational numbers. Find an irrational numbers between 1 by 7 and 2 by 7. So we need to find an irrational number between 1 by 7 and 2 by 7. So we know that the decimal expansion of 1 by 7 is 0.142857. It contains a recurring and it is a non-terminating decimal expansion by long division method, right? So we can take decimal. I will show you how it is come. So 7, so 1 is lesser than 7, so we need to put decimality. 1 becomes 10, so 7 ones are 7, it is 3. Subtraction, after subtraction, so we can subtract 7 from 10, we get 3. So 3 is lesser than 7, we take decimal. By taking decimal, here 7 4s are 28, so we can subtract 28 from 30, we get remainder is 2. Then by taking decimal, 2 becomes 20, so 7 2s are 14, remainder will be different. So 20 minus 14 is 6. By taking decimal, 6 becomes 60. So 7 8s are 56, 7 8s are 56, then the remainder is 4 after subtraction. So by putting 0, 4 becomes 40, so then it is 7 5s are 35. We cannot take 7 6 are 42 because 42 is greater than 40. So we should take 7 5s are 35. We get 40 minus 35, it is 5. So by taking decimal, 5 becomes 50, 7 7s are, it is 49. So we can subtract 49 from 50, again we get remainder is 1. So again the block 142857, it is always, it contains a recurring. So 1 by 7 can be written in the form of decimal expansion. So 1 by 7 is 0.142857. It is a non-terminating and a recurring. This implies that see 1 by 7, we need to write 2 by 7. So we know that it can be split into, so 2 has the numerator term 2 can write separately, then the remaining is 1 by 7. So it is 2 into, we know that the decimal expansion of 1 by 7 is 0.142857. It contains a recurring. By multiplication we get, see 7 2 7s are 14, 1 carry forward, 2 5s are 10 plus 1 11, and it is 1, remainder is 1. So 2 8s are 16, 16 plus 1 17, 1 is the carry forward, 2 2s are 4, 4 plus 1 5, 2 4s are 8, 2 1s are 2, 2 zeros are 0, right? After subtraction, after multiplication we get, so the value of 2 by 7 is 0.285714. Okay, so we need to write an irrational number between 1 by 7 and 2 by 7, right? So to find an irrational number between 1 by 7 and 2 by 7, we find a number which is non-terminating, non-recurring, lying between them. Of course, you can find infinitely many such numbers. Yes, an example of such a number is, after we have 0.14, so that is 0.15015015001540 etc. If it may be, and we know that there are infinitely many numbers between any two given rational numbers. So I am going to take, see, this is after 1.5 we have 1.16 0.15 2. So 2, I will show you how to write 2. See, this is after 0.19 we should take 0.2. So 20, it is 200, 2300, 2400 etc. Next, and also write Z 0.21, 0.220, 0.230, 0.240, and also we can write 0.250, 2500, 25000 etc. MCT is non-terminating and non-recurring, right?